features and the concept. Please feel free to ask, or if you know already things, I can also skip some explanations. Then I will switch over to Manu. He will present the end-to-end demo and also explain in more detail the code contributions. And yeah, we would also provide kind of the our status and our plans for the future. And we will be happy to take any questions either at this call or later offline as well. So let me start with like executive summary. So basically, Identity Mixer is a strong privacy-preserving authentication solution. It's based on digital signatures, so it provides strong security guarantees, but at the same time, it provides very good privacy guarantees. In that regard, it's much better than the standard X.509 or OpenID, and these protocols exist for more than 15 years. They have been verified by the scientific community, and a lot of this code has already been open sourced and even was at one point experimental service on Bluemix. So we think that IdentiMix is a perfect fit for a blockchain scenario because it provides better privacy and auditability guarantees without compromising on simplicity and scalability like it was in the case of Tcerts. And for different use cases, it's a really good fit. For example, like privacy-preserving asset transfer, or in banking industry, like when trading shares as well, where we have also a project called Liberty, where they have this strong privacy requirements, was presenting in also the Deutsche Bundesbank. They also require those privacy guarantees as well. And also in the light of GDPR compliance, there might be also a good kind of selling point for the privacy. It is indeed a differentiator for Hyperledger Fabric because it can, like all the crypto protocols and zero knowledge proof, they can provide basis not only for signing transactions, but also building in some more advanced privacy functionality on top of that. Also like answering already questions if you might have, because a lot of people when I present that have those questions regarding like hierarchical issuance. So because we also rely on the public key, we also provide a solution where we can have the hierarchy of issuers, but we don't need to reveal the public key of the lowest issuer, but we only reveal the public key of the root CA or any CA actually in the hierarchy. So we can present privacy in that regard as well. So we just published a paper that provides a very, very efficient solution for that. Regarding the status, so regarding what we contributed to Fabric, we'll go in the details in every on that point, but just so that you have a big picture in mind. So we already merged in Go crypto library, MSP implementation with the signing identity, a tool to generate all the crypto material like the issuer, CA's public private keys, and that issues credentials. And we also pushed, thanks a lot, also help from blockchain team, Eli, Angela, especially also Alessandro. We provide the end-to-end demo, and this CR is in a review now that basically provides, that we showed today, and that provides peer, like basically and runs end-to-end demo, so the peer can sign with Identity Mixer only in the command line interface, and the signature is verified. And in the progress is integration with Java SDK. So we pushed the crypto library. We're solving things with the dependencies, and we're working on the integration. So we'll make it kind of parallel, so without much refactoring or breaking the interfaces in the code. And we plan to have also Node SDK integration. We're considering also HSM support because we kind of realized that it might it's useful, and we also provide advanced functionalities. I have also slides about them, but I'm not going to present them now. But if you have questions, I'll be happy to explain all the advanced functionalities as well. Yeah, so basically, what is Identity Mixer? It's attribute-based credentials, so you get a certificate, which is a digital signature on a set of attributes. So in that regard, that can be verified with the public key of the issuer that you trust. So in that regard, it's very similar to X.509, but the main difference is that this signature is very efficiently compatible with zero-knowledge proofs. So instead of presenting the certificate in clear like we do for X.509, what we do is every time we present it, we create a fresh zero-knowledge proof of possession of the certificate that can hide all the attributes that we don't need to disclose and only reveal either certain attributes or even proof predicates about attributes inside the certificate. And this zero-knowledge proof can be verified by using only the public key of the issuer who issued the certificate, like a CA, which is called issuer in IDMX terminology. So it provides the privacy-preserving access control with selective disclosure of attributes, predicates over attributes, and full unlinkability, meaning every time you sign with the same certificate, it looks like it's a fresh certificate that is shown. Kind of, even the issuer cannot link two signatures with the same certificate together. But of course, you may not want to completely be unlinkable for everyone, really everyone. So for that, we have auditability property, meaning that you don't disclose the attributes in the clear, but you disclose them in encrypted form so that only certain auditors can go and decrypt those attributes. So that's kind of to provide fine-grained auditability property. And we also can provide revocation that is also preserving privacy and unlinkability, because of course we cannot use standard revocation like for X.509 because you will be linkable because you would have to reveal your serial number. So we provide advanced privacy functionalities for that allows to check for revocation status without revealing the serial number of a credential. So this auditability and revocation are advanced features. They're not provided right now in the crypto library that we pushed because we think it's better to do step by step, but we did already implement them in a big Java library, and that was also provided on Bluemix as a service. So this is just a matter of kind of adding that functionality slowly from that library to the fabric. And that would also be used, I guess, in another functionalities like privacy preserving asset transfer and another zero knowledge kind of functionalities. So yeah, and basically this zero knowledge proof is created based on the presentation policy. And what is the presentation policy? It's kind of a language that we developed for Identity Mixer that can specify which issuer should we verify the credential, so who issued the credential, which attributes we would like to disclose from the credential, either in the clear or, for example, encrypt it under some auditor's key so that only auditor can decrypt those attributes if needed. So basically, we have the whole kind of language that was developed for the big Java library, but for Fabric, we can, of course, adapt that language and simplify it and also integrate with the access control that is provided for Fabric for the attributes. So for now, it's just a simple, we just support whatever is supported in Fabric, this OU attribute and isAdmin attribute. But later, when the access control will be provided in the Fabric, we can also support that with Identity Mixer. Yeah, and so for permission blockchain, we have, I guess I can just skip the slides, the membership certificates. And if you show signed transaction with the same X.509 certificate, you would be full unlinkable and attributes are disclosed, unless, of course, you start signing encrypted attributes and sending the decryption keys around, which is very cumbersome for the key management. So the solution that was proposed in v0.6 was to use fresh X.509 certificates, and then you actually can be unlinkable, although you would still disclose the attributes unless you use this double encryption. And the certificate authority can still link those transactions together because the TCA is the entity who knows which batches kind of go together and link to with the same enrollment certificate. Plus the advanced access control plus auditability in that regard was not supported. So that's how it was done in v0.6, one enrollment certificate and many fresh Tcerts to preserve privacy to sign transactions in an unlinkable way. So, but how Identity Mixer works, it actually, by its nature, provides this functionality without all the kind of complicated building solutions kind of from that was done for Tcerts. So basically, as I was saying, how Identity Mixer works, you get just one certificate with the attributes from a CA, and then you can use this certificate and derive these unlinkable zero-knowledge proofs and sign transactions with that. And these signatures will be completely unlinkable, and the kind of the certificates that will be attached to the signature will be completely unlinkable, and you can also selectively hide attributes from that certificate. So it will be completely enough to have just one enrollment certificate and then use it to sign transactions in an anonymous way. Of course, you don't have to be only anonymous, because for some cases, like in the future, for example, if we want endorsers to use Identity Mixer as well, then we can also make these signatures linkable in a certain context or always linkable. We have like so-called scope exclusive pseudonyms for that. So you can really go from complete linkability to complete unlinkability with the IDMX. So it doesn't mean that it's only very unlinkable. So there are different levels of privacy we can provide. So if you compare it with the multiple X.509 Tcerts, so instead of using a batch, you would just have one IDMX credential and you would sign transaction with it in such a way that even the certificate authority cannot link those signatures together. So only the special auditors, if you want to add auditing, could link those transactions together. So now how the solutions looks like, I know the right side of the picture is like from the old architecture, but we only need to concentrate on this red box. So there is only one eCert now with Identity Mixer, and there is no need in Tcerts anymore, because you can sign these things unlinkable, sign transactions are unlinkable with just one certificate. So, and now I guess I will hand over to Manu. Manu, if you want, I can keep sharing, or you can share the screen. So Manu was working on the code contributions, and he can give you the overview of what is provided and which parts of the code we kind of contributed and submitted to. So
yeah, so if
are there any questions?
Marie, that's great.
Okay.
Are there any questions so far, or shall we move on? I guess we can move on. All right, so this slide shows the contributions we made to Fabric, and the core of that is the Identity Mixer crypto package, which is in Fabric IDMix, and that defines all the cryptographic algorithms that we need to do all of this. So the specific key generation algorithms and the issuance of credentials, and how we present such a credential, so which is essentially a signature, and how we can verify that. And building on that, we have made a new MSP, a membership service provider implementation. And so this IDMix MSP creates identities or signing identities that rely on that Identity Mixer crypto package, And so they sign and verify using our modified algorithms that bring all the privacy that we want to have. And so this can be used by a peer. Of course, we also need some MSP config files, and we have developed an ID mix gen tool for that, which is sort of similar to the CryptoGen that you probably know. So with that, you can easily create MSP configs for our identity mixer MSP. Then let's move to the end-to-end demo. So we've adapted the existing E2E CLI example that is in Fabric, and in this example we have is it playing yet, Maria?
No, but I can play whenever you tell me.
Let's go.
Should I play?
I'll go for
okay.
it. So here we have made a script that is similar to that example, and that will set up one peer, which has an X.509 based local MSP, which is part of an org with two MSPs, one X.509 and one based on Identity Mixer. And now we first create a channel and join a channel where we have some variable A, which is first 100, and then we're gonna invoke transactions, changing the value there. And we first do that with the X.509 MSP, and then we do that with Identity Mixer based MSP, and show that everything works together, and we end up with the result 80, which is exactly what we expect because we lowered it twice. So this shows that that they both work together and that we can do all the things we expect with this MSP. So let's go to the next slide, which is just to wrap up. So we show that that Identity Mixer can provide very strong privacy, and these are protocols that have been verified by the crypto community for a decade already. So we're very sure that the protocols work. It fits the blockchain scenario really well. So we don't need stacks of Tcerts, we only need one. And this will enable a lot of privacy-preserving solutions, like this privacy-preserving asset transfer. And we even have new technology for even more advanced things, so the hierarchical issuance that Maria mentioned, in which we can also still have privacy. And so this is what I showed you, is all merged in Fabric already, except the end-to-end demo, which we will polish a little bit more and then commit. And we already have some code for Java SDK also ready, which is in review, and that we expect to be done soon. And in the future, we still will make some more extensions, and of course do the Node SDK and support HSMs and have more advanced functionalities and add auditing and revocation and things like that. I think that concludes what we want to show you today. So we'd be happy to take questions if there are any.
Hi, this is Dave. I missed some of the setup on the demo there. Did you show that two organizations were used, and one used X.509 and one used Identity Mixer? Is that right?
That's correct, exactly.
Okay, and so I assume, like, if this goes into 1.1, you would not be able to have a 1.0 peer understand the Identity Mixer MSP. So I guess we need to turn on, hide this behind the compatibility flag, right?
That sounds correct, yeah.
Okay, we'll get you some more information around that.
Okay, very good.
Yeah, so this is Ale. So just commenting on that, Dave, you're right. You can bring up an ITMX MSP if you have the V1 capability. So if you have created the channel with the V1 capability and you have V1 peers, V11 peers. So,
what? So are you saying the capability is already there, or needs to be added there?
The capability is already there, so Angelo added it for MSP in general because we needed ways of distinguishing the behavior of MSP V10 and V11. And so the IDMX MSP is under the V11 flag, and so we're just piggybacking on that. So no new capability needed to be there. The MSP factory already uses the existing one.
Yeah, okay.
So this is regarding integration with Fabric CA. There shouldn't be a lot, right? It should just be the ability to get a get a certificate. Sorry, not an X.509, but get an eCert that has the proper signature, right?
Yes, exactly.
Sorry, go ahead, Maria.
Yeah, so basically we would need to, so we preserve like the interfaces, but we would only need to replace the cryptographic signature with the identity mixer signature and the data that is kind of wrapped in the request.
Okay. So on the roadmap, that was not, wasn't clear on planned. It wasn't listed under planned, but
yeah. Sorry, yeah, it's definitely in the is the first point. Yes, sorry, yeah, I kind of missed that.
Okay,
yeah, that's a good point. Yeah.
Okay. Go ahead.
I don't want to interrupt. Go ahead.
I was going to go to another topic if you wanted to comment on this one.
Maybe it's just sort of, I just want to recap that. Is the we used to do an enrollment and we get X.509 certificate back. Is it we just do an enrollment and because the public key in there that we're sending somehow that the Fabric CA knows that this is now using Identity Mixer and what we get back is something different? I don't follow how that integrates.
Yeah. Well, the eCert request would have a different flag in it, or perhaps we would use a different URL. We don't know yet, but it would. I think from a SDK, Rick. This is Rick, right?
Yeah.
Yeah. From a SDK perspective, I'm sure it would be similar request, but then you'd be using let these guys speak. What would happen differently once you receive the response from the Fabric CA would be, yeah.
So the mechanism as of yet, how we distinguish and use to the Fabric CA, whether it's Identity Mixer or the old just regular eCert, has not been yet set.
No. So
we might use maybe the same approach as for MSP, ID, so we can probably add the crypto provider ID in the request or something like that. But we didn't discuss that yet.
Right. So I don't know if this is you went over kind of auditing and revocation very quickly. I don't know if you want to maybe talk about that a little bit more. Like for auditing, for example, is there? You mentioned you could insert an auditor. Where would the and it would not be subject to a Fabric CA like in the old model, but where would the auditor? Who would give the auditor permission, and what would the overall flow look like?
Okay, so basically how it was implemented already in all the kind of POCs and systems that we did already. So basically kind of TA does need to be involved necessarily, but it can also play a role of the auditor if needed. So, but what we had was like a separate entity called auditor that had key pair, secret key and the public key, or private key and the public key, that the private key is only known to the auditor. So we have like a smart card with that only the auditor knows, in possession of. And then the public key is distributed in the system. So basically, the public key is included, the reference to the auditor's public key is included to their presentation or access control policy that Identity Mixer credential, or rather presentation token, needs to satisfy. And then whenever Identity Mixer credential is transformed into like the zero knowledge proof of possession of credential, then it's not only like the attributes are selectively hidden, but also one attribute which is used for basically auditing. So I call it like enrollment ID here on the picture. It's also encrypted with the auditor's public key, and the proof is provided that the same attribute that is inside that ciphertext was indeed signed inside the credential in zero knowledge, so without revealing it. And the whole and this ciphertext is also attached. It's kind of blended inside that Identity Mixer signature or zero knowledge proof, if whatever you want to call it. And then whenever verifier verifies that signature, it needs both the public key of the auditor and the public key of the certificate authority to verify this proof. We can also add another layer of privacy and basically hide the auditor public key inside a set of auditors, for example, or we can also add another feature that not only single auditor can decrypt, but we can split this secret key of the auditor among a few auditors, so only when they come together then can decrypt. So for decryption, the verifier would need to send the ciphertext from the signature to the auditor, and then the auditor can decrypt the ciphertext. But what the zero knowledge proof ensures is that the same enrollment ID was indeed signed inside the certificate. So this ciphertext is not encryption of something random.
Okay. So the auditor is able to see the revealed, like on a per attribute basis, or
yes.
Yeah. Okay.
Yes, it's on a per attribute basis. So it can be enrollment ID, and then the auditor can go to the certificate authority, who can map this enrollment ID to all the other attributes or the real identity of whatever, a user or entity or a peer, and then the whole revealing process, or I don't know, whatever you would like to do after the auditing can happen.
Right. Okay.
Or you can also encrypt few attributes as well. Doesn't need necessarily to be one attribute. It's more efficient to just encrypt one unique attribute and look up the rest like in the clear with the certificate authority.
Right. Okay, thank you.
All of them were fine, like the first four, right?
I mean,
any other questions?
I mean, I had others, but I'd like to, if anyone else has some.
This is Rick. I was wondering, what are the impacts of this on top of if the client is running in an HSM environment where there's a private key and the hardware only? I assume that all that works and that's kind of tangent to this, or are there wrinkles with that?
I went ahead and finished these tests.
So we had already implemented the mix in the last years with the smart card. So where basically the secret key of the user was on the smart card, and the smart card participated in the signing protocol with this certificate. So we can provide this separation, like with the secure element, with storing the key in secure element. What would be different in that case is that we would need to provide the custom implementation of the algorithm itself, because the HSMs, like out of the box, will not support Identity Mixer crypto algorithms. So we can we can preserve interfaces, but we cannot preserve we cannot reuse the same implementation that are in the standard HSMs already. So for that, we would need to implement identity mixer protocols inside the HSM, but we won't break them like PKCS11 interfaces in that regard.
Right.
So like key management will be done in the same way. It's just the signing would be different from like ECDSA signing.
So that would seem to be a like if customers have HSMs that don't have that capability, then that would be one reason they might not be able to use it then until that was implemented, huh?
Yes.
Yeah.
But we can also provide like our HSMs that will support that, or we can also I don't know, open source the code for that. I know that putting the code inside HSM is a long and careful process, but if we provide like reference implementation of with the preserving the interfaces, this is still easier than breaking the interfaces and making HSM, like for example that was with Tcert issuance. So all the key would be like all the key objects will be still treated in the same way in that regard.
Have you been working? How could you speak a little bit to how this may relate to the whole Indy project with regard to verifiable claims? Because I know they're using zero knowledge proofs and decentralized identities, et cetera. Is that a big? Is that something you can speak to or?
Yeah, so I'll start, and I guess I'll also let Manu to add. So basically, the Evername came to us like a year ago because they wanted to collaborate because they used some of our algorithms that Jan invented many years ago. And so they were kind of consulting us on how to use them in a proper way, like for privacy preserving revocation and so on. So their view on how the identity needs to be done on blockchain is very similar to our view, basically. And they also wanted to have all the privacy features enabled. That's why we had like we were in touch with them and like more in kind of exchanging knowledge. But now they visited us, and I wasn't involved, but Manu was involved in that meeting. So I'll let Manu speak on what are the next steps in that regard.
Yeah, so we talked to them, and indeed we have a lot of the same ideas. We have some plans to sort of make shared specifications of how we think you should do these verifiable claims. So in that sense, to make sure we're on the same page there. I think they have a similar, they have some implementations also of these zero knowledge proofs, but that looks not very mature yet.
And it's in Python, I think, right? They have like a Python library.
Yeah. And they use very old versions of the anonymous credentials.
Yeah.
Yeah, but the goal is to have like a common crypto library and define the common interfaces, and then also pursue standardization with like W3C, so that we're all kind of on the same page and not everyone using different like language and standards. So we will be part of that kind of effort as well together with them.
Okay.
And also later, maybe would move Identity Mixer library, like the core crypto library, outside of Fabric, and there's a separate open source and rather vendor it in the Fabric. But that's for later step where we define this like interfaces and standards and so on.
Okay, thanks.
Are these attributes that you described similar to the X.509 attributes? For example, they can be used in chain code for access control decisions?
Yes, so we basically implemented now the OU attribute and the isAdmin attribute. So they're basically kind of arbitrary strings, so can be like dates and so on, that can be used in the same manner as X.509 attributes.
Okay, and maybe this is more of a question for Keith, but Keith, you know how there's the new chain code APIs to get the certificate information and to get the attributes. Would those APIs apply to here as well?
Yeah, I mean, we have talked, we shared, we did meet and talked about those APIs, and so I think the goal is to implement the same. If it's an ITAMX credential instead of an X.509 based credential, then you should be able to get the same, implement the same APIs. I mean, it's really just getting a value out, right? And this is, I think, where we need to be. You mentioned earlier, Maria, about the being able to say a predicate, like, for example, someone age is over 17. That I think we need to be crisp about how that's exposed at the chain code API layer, right? To say, is it simply a string that is that a chain code writer is going to look up and say, how do they reference that predicate? I guess is from the chain code writer is something, and that's not something that we expose in the chain code APIs today. But going forward, we need to make sure that it's compatible between anything that we do on the X.509 side versus ITAMX.
So, Keith, if I may intervene, hi, this is Ellie. I just wanted to say, bring back from some discussion that we had, all of us, in the past about this chain code attributes-based access control. I think on that Jira item, we all concluded that in the end, we would extend the standard MSP interface with some attribute-based policies, principles, evaluation possibility, and that the chain code could essentially redirect the call for attribute verification to the peer who would be able to do it. So.
Okay, well, I think if every access control decision requires going back to the peer, that would be. I don't know that I'm not sure that we need to do that. I mean, I think the other option would be that we get the MSP definition is accessible in the chain code, and then you simply are able to make the access control decisions there. I'm not sure. What would be the advantage of one over the other?
Well, in the peer would be once and for all implemented. If some attributes a user has been, for example, revoked for this, you would only need to update the MSP in one place. Otherwise, if you rely on the chain code to do the validation of a certain attribute, you will need to update each and every chain code with changes to the attribute related revocation list, for example. Anyway, maybe if it takes long to discuss this, maybe it's a topic for an offline discussion. But I just wanted to bring back this discussion that we had in the past, because I thought we had concluded at that point in time, at least on that Jira item, and it's relevant.
I don't know that we definitely said we're calling back into the peer every time, but anyway, we can. I guess, Dave, to your question, I think we definitely agreed on the APIs and how those APIs are implemented should be opaque to the caller. That's the important part, right?
Right.
and yeah, that was going to be a post V11 thing anyway. So.
Okay. Speaking of kind of the roadmap, is there? I see you got the planned items here, but is there a kind of a roadmap of what's there now, what you think needs there to be there for it to be production ready in 1.1, and what might come after 1.1?
Yeah, so basically, for whatever is needed for the tech preview for inside the fabric in terms of end-to-end demo is ready. So what we also targeting for the tech preview is the Java SDK integration. And that we expect to be ready in like a couple of weeks. And I know that the release of Java SDK is, I don't know if they're entirely synced or they go a little bit after the release of the fabric. But the code that is kind of goes with the fabric is already merged, except this end-to-end demo, because we had some discussions of whether it's will be merged or not, but it will be merged like as an integration kind of test rather than like the functionality that we provide for the peers in terms of signing, because in the end-to-end demo, peer kind of plays a user to sign transactions, so because it's completely goal-based. So for that, we agreed on how we proceed to get it merged so that people are not confused and want to use it, like try to use it straight away for like gossip and endorsements. And then, we expect also Java SDK to be ready in a couple of weeks. So we're also solving now issues with like dependencies to get it proper in a Maven repository and working on the integration. So this is for the tech preview for 1.1, and then the planned things are post this tech preview. Will definitely be the Fabric CA and Node SDK integration first, and then we look at the advanced functionalities and HSM support. So I don't have like a timeline in terms of concrete dates, but I can also open issues with like expected deadlines as well for that if needed.
Okay.
Go
ahead.
The one concern of going back to the HSM is I know that like CLS, they have their own HSM library, and I don't think we should be able to say, well, you can't run with another HSM library. I think we need to have also something in there that shows how you would integrate some API, how you would integrate this to a PKS11 type environment, and it should be able to work then for whether it's IBM's or the one that CLS is using.
Yeah, we will be working with basically the team that contributed also to the crypto implementations for the crypto card for that. So like with Tamas and Christopher and Silvio. So, and we will work with them on basically like clarifying it, and yes, we provide that description as well. So we will work with them who really know how to do that integration. So we won't just do something what we think is good, but we will make sure that this indeed makes sense. So we'll work with them on that integration with HSM.
Yeah, I just off the bat, I'm just wondering why the interface is a PKS11 type interface, where you can support IDE Mixer on top of just using that.
Sorry, I didn't get the question. Sorry, could you please repeat?
I'm just curious as to, well, there's probably something offline, but PKS11 is like an interface, right? And so
yes.
I'm just wondering why that, it seems like to me that's what needs to be pluggable, right, for ID Mixer
and then be able just to use PKS11 type interface so that it integrates in.
Yeah, that's what I was saying. So I think we're able to preserve because you also use like sign with the secret key type of queries to the HSM. And that's indeed what IDMX does. It's just instead of ECDSA signature, it does this part of the zero knowledge proof or the blind signature for issuance, like Kamishli-Sanskar signature or BB plus signature for, Yes, but the goal is, and we think it's will preserve the PKS. What I was saying, that we need the custom implementation of to support the mix crypto algorithms, basically.
Just an additional remark. I don't know if it has been mentioned before as well. I think it was Rick who was talking about the HSM support. So Identity Mixer will initially provide client identification or authorization support. The peers will continue to operate as they operate currently. So they will still be able to use HSM directly using their standard enrollment certificates.
Yes, exactly. Yeah. But I guess if we would like to support, like HSM support for the CA, then we would need that integration. But for now, we indeed, that is right. I think I forgot to mention that, but to kind of stress on that, we don't need immediately the HSM support because the peers will still use X.509. They will only use IDMX for verification of the signatures from the clients.
So, sorry, I'm now that confused me a bit. So we have, for an MSP has to be a particular type, either the default X.509 or IDMX. And if you have a peer that is using an X.509, how would the client that's part of the same MSP be using IDMX?
So the client would create a transaction proposal with IDMX MSP, and then we'll send it to peer, and the peer will be able to invoke the right MSP. So use like channel MSP to verify this transaction proposal, and we'll use local MSP to sign for endorsements, basically. Okay. So the peers will be able to switch. We don't set up the mix as a global MSP, like a local. It's called local MSP, I guess, in that context.
So, okay. So in the channel, and we can take this offline if it's clear to everyone else. But if the so if the channel in the channel config, you're going to have if there were other clients using this, some clients using the IDMX, and then one client using a peer that is using X.509, is the channel config going to just contain a single MSP?
Can you repeat your question, Keith?
Yeah. Okay. So you got two. We'll say you have two orgs. One org is using the default. The second org is using the peer. Is using the X.509 based, but then you've got a client that's using using IDMX credentials. Are they? Does the channel config just have what is in the two MSP? What's in the MSP for that org that allows the IDMX credential?
So in the channel now we are very flexible into defining policies. For example, you could have one MSP that defines the client of a certain org, another MSP that defines the peers of a certain org, and then set the access policies in such a way that would, or the resources access policies in such a way that would allow the peer to receive invocations on given system changes using clients also having signed with this MSP, say, with the identity mixer MSP of that org. So you are able always to configure your channel access to your channel resources such that the identity mixer MSP users, members, are given access to it. The only sort of corner case is the gossip-related messages, but because gossip messages always relate to peer talking to another peer, then we wouldn't meet any issue there, I suppose.
Okay. Yeah, I assume. I mean, this is exactly what you had to do in the end-to-end demo you just showed. So, right. Is that correct?
Yeah, I guess for the end-to-end demo for one peer, we created it as also as a local MSP because we wanted the peer to sign, like it was the user, but in like that's just for the demo and to kind of test the end-to-end technology, like from beginning to the end. But in the real scenario, the IDMX MSP will be only the channel MSP and not the local MSP for peers. So the MSPs will be able to verify with Identity Mixer MSP and will still be signing in the gossip protocol with the X.509 MSP for now. So in the next releases, we might as well consider signing with the Identity Mixer MSP as well in the gossip protocol, but there we need to see what kind of adjustments we need to make to support that because of the unlinkability properties that Identity Mixer provides. So there we need to add additional functionality for the identity so that the peers can reuse the same identity in the gossip protocol.
Right, okay.
So this local MSP versus global MSP concept is new to me. So by global MSP, you mean those are the ones that the channel knows about?
So I think global, Maria, do you mean the verifier MSP, or the global MSP?
Yeah, sorry, I might be kind of using wrong terminology. So I thought like local MSP is something that is used by peers for signing. And then the channel MSP is something used for verification. So maybe I'm using the wrong terminology here. The global meaning, like, so peers will be able to verify with Identity Mixer MSP and will be signing with the X.509 MSP. So I don't know, Eli or Manu, correct me if I'm wrong in that terminology.
No, I think you're saying it right. So for the E2E demo, what we did is we have two orgs that are a member of the same channel, and so the peer uses X.509 and the clients use Identity Mixer. But of course, everybody knows about all MSPs and can verify all signatures.
So the verifier has a similar structure, you mean, but it's not exactly the same. The verifier MSP has the same structure. It has a issuer identity that is listed as an X.509 certificate containing the special issuer public key of the Identity Mixer. But it's not actually a certificate that complies fully with the X.509 standard because we have this special public key included in it. Would that answer the question?
but we are happy to discuss that offline. I'm afraid I have to jump to another call where I'm supposed to present right now. But we'll be happy to set up a separate call and to clarify that.
Okay, thank you.
Yep, thank you. That's very helpful.
So is there any follow-up or decision after the playback, or is just for that everyone is on the same page, I guess?
Starting off to get everybody on the same page. I was kind of alluding to before, I'd kind of like to see the roadmap of written down about things that are in now, things that you think need to get in for this to be either tech preview ready or production ready in 1.1, and then things that come after. So if somebody was taking notes here, they can put that in the JIRA work item.
Okay. Okay, I already have JIRA items for an epic for whatever is merged and in review, like the first 2 points, and for the in progress and planned partially. So I will add the remaining basically JIRA epics as well. They are connected, of course, they're related. And I can also provide a slide where I summarize everything.
Okay, yeah. If you could put everything up in the JIRA, I think it's 2005?
Yeah, so 2005 is the first 2 items, like the whole Fabric integration. And there is another epic with Java SDK and then another with Node SDK. I will provide then the JIRA items for Fabric CA and advanced functionalities. There is actually for advanced functionalities, there is MVP, post-MVP version of Identity Mixer. I will update that.
Yeah, just make it clear.
For post.
In 2005, just add the some meeting minutes under the comments, and you can put the links to the other items.
Okay.
Okay.
Okay, well.
Thank you, Maria.
All right. Yeah, thanks. This is a very good playback. Thank you very much for that. I'm recording this, and I'll figure out once I get the recording, I'll post the link somewhere for those that have missed it, and I'll put it out there publicly. Is there anything else before we close the call? Okay, we'll close the call. And then just a reminder, there's a playback again tomorrow at the same time, and we'll use the same WebEx setup. Okay, thanks everyone.
Yeah, bye.
Thanks.